Hello, everyone, and welcome. Thank you all so much for joining us today for this live stream event. My name is Alexia, and I am the program manager of the Microsoft Reactor Toronto. I will share the session resources with you in the chat. But before we begin, I'd like to quickly review two items: our code of conduct and event guidelines. First, please take a moment to review our code of conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. And secondly, our event guidelines. The session is being recorded and will be available on demand through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I will share the link in the chat for our on-demand content. And if you have not been on a live stream to YouTube before, please note that you must create an account on YouTube in order to have access and interact in the chat. You can set that up now. And if you're unable to use the chat but have questions, feel free to reach out to us through social media or on our website. Which brings us to today's session. I'm going to bring in our speaker here for today, Sihan. Hello, hello.
Hi, Alexia. Hello, everyone.
Welcome to the Reactor. We're very excited for today's session and having you on.
Yeah, I'm really excited too. So there is a lot of content we will see here.
Fantastic. Well, so take it away.
Okay, thank you. So welcome everyone, and welcome to my session about building a production scale conversation AI assistant with RAG capabilities. Let me just move from slide. Yeah, my name is Gian Sinar, and I'm a software architect with more than 10 years of experience. Currently, I'm working as a software and AI architect for a Swiss company, which is Givaudan, specialized in fragrance and flavor. And I have been doing some conferences, so you can find some of my work on my socials. Feel free to check them. And this presentation will also be published. Let's get started. We will talk about production scale conversation AI assistant. And in this one, we will go through a lot of topics to be able to build this solution. So at the beginning, we have our user. We need to have this UI UX experience to be able to chat and to be able to have this history of conversation. So we'll see how to manage this part. We'll have this orchestration layer to be able to distribute correctly what we wanted to do. It's a RAG, it's image generation, it's just a conversation, and how to manage this in memory. And this one is connected to large language models. And the final part we'll go through, it's going to be the vector store. So to add knowledge to our large language model. So to bring more knowledge in this case. So we will talk about each one of them during this presentation. First of all, I wanted to start with the chat completion, which for me it's really important here to understand, to be able to create a chat API. So what is a chat completion API, for example, in large language models? We will talk about more OpenAI to take example in these cases, for example. There is some difference. We can send a conversation in OpenAI and not a single message. And this is something different from previous completion models. So you can send a lot of messages here, and you will have a single output as a message out. And this large language model are token based, and it's important to have this in mind for the following step. It's so it's not only text or word based, but it's token based to be able to do all the semantic connections. And the second point for the chat completion, it's the context window. On this part, you can't be able to send an unlimited message as an input, even if your conversation going bigger and bigger, so you will have a limitation. Basic common models previously had like 4K input and 4K output of tokens. Currently, with the newest model and increased capabilities models, you can have hundreds of thousands input, and even in the output, you can have a lot of tokens in the output. But we need to manage this limit if we wanted to have a longer conversation. So how a chat completion API is working. So in this example, we are calling, for example, the chat completion API. And to chat with them, we need to put some basic API models like the model GPT-4o and the messages. This is the most important part. You will have different roles, system, user messages. And the system, it's basically how your LLM will answer you globally. So you will not have to send them every time. So you can set up this thing and you'll be able to have this way of working, and it's not directly on the prompt. You can hide this, for example, in the conversation of the chat. And the following messages, you will have a few user and assistant messages. In this case, for example, we ask to tell how to care for a parrot, and the response of the large language model, it's a message content with the answer. What will happen if we ask a new question? We will have this message append in this array, and we will continue to ask user and assistant messages. But as we discussed just before, we will reach out to a context window. In the beginning, we'll not have any issue because the token for these limits will be enough. But how to manage conversation memory? So, for example, I think a lot of us have already these feelings like, oh, I'm on ChatGPT, I'm asking a lot of questions, and the first thing I discussed before, he don't have this, and I need to repeat again and repeat again. So because ChatGPT doing this management of the memory, and there is few ways to do it. There is a buffer and a summary mechanism. So if we do nothing, as you can see on the blue line, at a certain time, you will reach the token limit and you'll be not able to send new messages. But to manage this, the easy solution is to manage a buffer window, the yellow one or the orange one here. And the K, it's just the number of messages we wanted to keep in the buffer. But it's not really good because you will lose your oldest conversation will be not included in your new chat, and if you just want to keep one single chat, you'll be not able to ask question you asked previously. And to handle this part, there is another mechanism which is the summary of the conversation. So you will summarize the previous messages, and in this case, you can have the max token limit. So you'll be able to say, okay, I will just summarize my conversation when I will reach a certain amount of token and not before. And with this mechanism, you'll be able to keep this knowledge. You will lose some data, but will keep this knowledge for the conversation. Another API, ChatGPT with the new version and other models are currently becoming multimodal, but multimodal in the input. And for example, I wanted to display here another one. It's an example when we generate an images, we need to call a different endpoint, like the image generation endpoint of OpenAI on Azure. You can it's a basic REST call with just a prompt and some sizing and quality fields. And at the end, you will have your endpoint, your response with the image generated. You can have it directly in the endpoint, so you can download it, or directly in the base 64 format, so you'll be able to just take it and iterate on this topic. And finally, let's talk about how RAG is working. So it's a bit different on the conversation part, because on this, what we need to do, the idea here is to bring knowledge on the answer of the large language model. And for this, we will take example of documents and PDF and to integrate this in our knowledge. To start, the first thing we need to do is to do a document ingestion pipeline to be able to to convert this document into something usable to the large language model. After the data is ready, we need to, when a user will query the large language model, we need to do transformation to be able to call this base of knowledge, to do this search in the database, and at the end to be able to answer correctly to the user with this base of knowledge. I will go through all of these 4 points. So to start with the document ingestion, you start with your source material. The first thing you need to do, you have to chunk your documents. So because the documents will be too big, so you have to chunk with some knowledge your documents. And the chunk, it's mainly just a text block. It's really important to split them correctly and not a single document, so it will be not really useful when you will ask some question to have something really precise. And when you have this chunk of text, what you have to do is to call an embedding model. It's like the GPT-4o model on OpenAI, but here it's embedding models on OpenAI. You have other models available to do this job. And what you will have at the end for each of these chunks, you will have an embedding representation for each of them. And the final things you have to do is to store all of this combination. So each chunk have his own chunk, his own embeddings. So you have to store all of this information in your database to be able to query them in the second step. Our data is ready. Let's talk about how to transform our user query into something readable to our database and to be able to do this research. The first thing we are doing, we have this user query in text format. We are doing the same process we did before for the ingestion. We are calling an embedding model to get the representation of this user query. The second step is to do the research in the database. So we have some libraries to do the semantic research, for example, in the database. And the vector database is what we prepared just before. And we will do the research with the best result here. You have some option you can work on this to be able to work with some of the work. For example, you can integrate some metadata in the vectors to query them in a more precise way. After getting the top results corresponding to this vector results, what we will do here is we will create a new prompt which will contain the user query, which will contain all of the best results found in the database, and we will bring all of them to our large language model to be able to answer to the user. So this is the full workflow, the easiest one when we try to integrate a retrieval augmented generation, so to have some more knowledge in our query. Instead of just doing user query, calling the large language model, here we need to do all of these steps. Let's talk a bit more on Azure AI Foundry. This is an awesome tool on Microsoft. It's a platform to be able to build AI solutions in a single place. Initially, the announcement was done a few months ago, and with all of these features, initially it started with OpenAI deployed separately, with other like document intelligence or other services available on Azure AI Foundry deployed in few Azure resources. And this platform here will bring all of the Azure AI capabilities. So in a single place, you'll be able to manage your Azure OpenAI services, your AI search. It's mainly your RAG, so how you want it to do your ingestion of documents, integrating some documents, and how you want it to chunk them. The other part, which is really, really important, is the model catalog. You don't have only OpenAI on Azure AI. I will go through all of them just after this slide. You have a bunch of models available, so it's really cool to work with them and be able to use them in an easy way. And on the bottom side, you can see the observability. There is a lot of tools bring here to doing the LLM evaluations, the monitoring. You have some safety and content policy you can manage in this place. And you can connect all of these things with the tools already on Microsoft, or even without. There is a lot of codes and SDK available to be able to work with all of them. Thanks. So let's have more real use cases in this case. So let's take me back my presentation. So I'm on Azure AI Foundry. It's ai.azure.com. This is the home page. You can see in this page that I have few projects. I created the one for this demonstration purpose. And you can see other services available. So the Azure AI service here, you can see what's available. There is a new UI on OpenAI, which is a bit different from the project one. And you will have the other one we just talked before. So if I go to the model catalog, you can see the newest announced project here, the Mistral one, for example, the GPT-4 4.5 preview. They just released the Llama 4 model too. You can be able to check all of them. Other tools, which is important, it's the model leaderboard. So in a single place, you'll be able to compare your models, to check the cost. You can just browse. Let's wait a bit for the loading, and you can here iterate and check the cost of the model, compare them. If you wanted to use some of the models and to compare the model, you'll be able to see a lot of tools here to help you to decide, to validate the cost, and to do some tests. Let's get back to the model catalog, and you'll be able with this filter to change and to see the model you want it to work, if it's just a chat completion or there is new text, the image-to-image model from Stable Diffusion, or text-to-image models. You'll be able to go through all of them here. If you go back to the home page, you can see here the Azure AI services. This is just a way to see all the AI services available, like the vision and document capabilities, to parse and do OCR on documents, to be able to do translation services, dedicated services available here, or speech to text, text to speech, even if it's not on OpenAI directly. So you will have a lot of tools in this page. And the last one I wanted to show you in this portal is the OpenAI services. If you go, you have a different portal on the OpenAI. So you select your OpenAI deployment. I already did the deployment to not waste time here. And you will have a bunch of capabilities on the left. You can see again the model catalog. And the most important one will be the deployments one. In this case, we'll be able to see the model I already deployed, the GPT-4o mini. You'll be able to click on this. You can have your deployment endpoint, your key, something which is really cool. You can have a snippet of code for your preferred language. If it's, for example, with Java, so you will have the library. If you just want the raw request, you can have the REST result with curl, for example, and just check the endpoint and how to integrate this in your current solution. And you will have some metrics. So in this case, for example, you will see how many requests is done and how many tokens it's used. It's really important because when you deploy a model, you will have a limit of token you will have to set up, and you can here manage the size and what you want it to do. You have the risk and safety. It's good when you wanted to manage some filter and you don't want some things to be not done, and if something using your models in a bad way. And another section to have some snippet of code you can use in an easy way. We'll just show finally the project on Azure. If you want to not use Azure AI with OpenAI, but with other models, like with Mistral, for example, you can go through here, and to do your deployment, you can directly check out the model and do the deployment, and you can go here and to check all of your deployments available. And you have new services here on top of the OpenAI. Like if you wanted to create an agents, you can create your own agents here with some of the capabilities to connect with RAG, or you can just use prompt to flow to create improved AI logic with your application, to not just have your single prompt, but you can manage a lot of things in this area. And finally, you have some monitoring and evaluation tools in this part. You can use them for doing your LLM evaluations. Let's check our OpenAI deployment and do some tests. So I already deployed my my services here, and we can, for example, start by just updating Act as a pirate, for example. And this is the system prompt. I will just apply my change. And here, what I will ask is, tell me a joke. And because of the prompt system, I don't have to repeat again, and it's talking like a pirate in this case. It's working well. We can just, which is important in the memory, in the conversation, because it's chat completion. So if I ask another one, not so one, for example, it keep the conversation memory in this case to what you just asked before. Let's just give an example with an assistant now. I just wanted to show you an example of RAG with some knowledge. I already created a vector database. So let me just show you. I created a vector store here with some knowledge. If I open it, you can see I just uploaded my presentation. And this version of OpenAI will do for you the all of the pipeline I just showed you before on doing the chunking and etc. So if you wanted to use them directly and not have to deal with them locally with code, you can use this platform to just do all of these chunking things by Azure. Our data is ready, the chunk and the store. If we go back to the assistant, and so I have an assistant name, same thing, act as a pirate. And this is the way I wanted him to ask. And because I just put my data here, I will ask something about SDK. I have some part in my in the last slide talking about how to use which SDK I can use to integrate large language model, and I will ask him how to implement RAG and with which SDK. As you can see here, I have a request done. I will just maybe close this. Yeah, it's better. When I started, there was a loader saying searching on my documents. So, and in this case, we can see there is a search directly in the documents on how to deal with it. But we need to be careful on some limitation because the chunking will sometimes, when you don't deal by your own, chunk a lot of context here and maybe not too useful slide by slide, or you will not be able to manage all of them. But it's an easy way to to start doing a RAG. And because of what we wanted to ask, you will not be able to have all of your answer because the parsing of some table or something like this can be a bit complicated. But when it's just raw documents like Word, PDF, or something like this, it's really easy to chunk this data source. And for example, you can just talk with this and start the same thing. Tell me a joke, and we just have this knowledge here. So it's really easy to chat with the documents. Okay, we are good for this presentation. Let me just go back to here. We talk about Azure. We have a lot of capabilities, and we know for what we can develop and use them for doing AI applications. The second one I wanted to talk is how about a real world solution already in place. At Givaudan, what we did is we implemented our internal secure ChatGPT solution, working with Azure and with Azure OpenAI and with what I already just showed you before. We wanted to have these tools to be able to not go outside of our security concern and sending some data to OpenAI directly, and wanted to have a secured solution on Microsoft. And it's why we worked on this topic to integrate this. Let me show you the demonstration of Alfred. This is the name of our secured ChatGPT solution here. As you can see, just not up to date, but it's a chat UI. We replicate it like for OpenAI and other tools. You can just start here and to ask some questions, but the prompt system is already done in the backend side. So if I want to have more instruction like act as a pirate, I can just say it again here and tell me a joke. And this is the same thing we can have in the playground and on what we are chatting. We are just use the basic libraries to chat with them, not really complicated to put in place, but we have to manage all of this conversation memory. So I can here, for example, ask again another one. So I will have a new joke and it will take care about, I wanted them to act as a pirate and tell me a new joke, not necessary to ask them a new thing. We don't implement it yet an agent system. So if we wanted now to do just the image generation, we need to call a dedicated endpoint to do this. And if, for example, I want a parrot at the beach, and here we are calling DALL-E 3, the OpenAI model. It's taking usually 15 seconds to generate an image. It's not really quick, but it's a good way to start with OpenAI directly. And the image quality is great, not as great as Midjourney or something like this, but they recently released the new models, not available yet on Azure. But you can use the API here to chat, and you can iterate your conversation. Last thing I wanted to show you, it's our RAG. So we separated the logic with the chat and the RAG. And here, for example, I can ask, what can you tell about lavender? In this case, we just updated the prompt system to be able to only get the knowledge from the source of documents. And in this case, our RAG solution is based on two types of documents, PDF and HTML file. So we did all the ingestion pipeline. And the thing which is really powerful, it's when we are answering, we are getting the chunk on what the document is based. And this is really powerful because our user wanted to have knowledge based on document source and not only on LLM who can hallucinate. So I can just click on the document here and I will display my source of document. I can have the extract of the exact chunk used to answer to this question. And we can have the document to be displayed here. We're just downloading the document source based on what it's answered, and we can have the source of the HTML file. Here, it's not directly it's just a link on what the RAG is based to answer this. So in the chunk, in the semantic research, what is that? It's the best result was these two documents. That's it for Alfred. And finally, go back to our presentation. Okay. I wanted to share some KPI here after more than a year of production with Alfred. We reached out of billions of tokens used in production across all the employees, with 500,000 requests totally, and it's just for one of the models and not with the RAG. So this is really, really cool, and we have a lot of adoption and a lot of usage. Few words on the Alfred architecture. If you wanted to have in mind, you can work and to develop your own based on the technical stack you wanted to use. What we are doing here, we have our private network at Givaudan, and with our user management. The deployment of this part is done on AWS because we already have a cluster on AWS with our infrastructure, our OpenShift infrastructure for other projects. So what we decided to do is we are using mainly what we know. It's Angular for front-end. You can use whatever you want here. It's not really important. In the backend, you have a lot of libraries with Python, Java. So in this case, the most popular one when we started 2 years ago for the developments was the Python backend with Django and LangChain libraries. And the database, the vector store, it's on a Postgre database, and we are managing all of this connection with our infrastructure, doing the connection with our internal user management with the OpenID Connect on AWS. We already plan to move to Microsoft Entra ID. And finally, we have the connection to Azure for all of the AI capabilities. In this case, as backend platform, it's connected to the API management platform on Azure, and load balancing directly to the OpenAI solutions deployments. You can directly connect from the backend to the OpenAI deployment, but it's not recommended if you wanted to manage this in a better way, in a security purpose, not to expose everything and to create private networks. This is the current solution. We are just will do some modification in the architecture, even for the RAG to improve the RAGs and how we are doing the ingestion and the solution directly on Azure with Azure AI Search, for example. And if we go back to our overview of what we presented, I just wanted to put here some framework you can use, technology in the front end, in the back end. There is a lot of every tools working well. Some of them it's not as updated like some Python library for the backend. And in the LLM catalogs on Azure, you can have a bunch of models, but you can use other models too. If you host some custom model, you can just in your orchestrator manage these parts. And for the vector database, we are using Postgres, but we are studying new way to do the RAG with the Azure AI Search. There is the CosmoDB in Azure, which is really, really powerful to develop all of this workflow in a single place on Azure. And finally, what I wanted to talk, it's about SDK. So you don't have to manage this curl, this post call, for example, when you are doing your conversation. There is a lot of SDK doing all of these calls directly. Azure is doing a great job here, so it's well integrated with their platform to connect OpenAI for other LLM solution with Azure AI Search. So you have a lot of SDK you can use here if you wanted to do some complex agent with semantic kernel, or if you wanted something separate, you have long chain library, lot of things integrated here. Or if you are using Spring Boot, for example, for Java, Spring AI is working well, not fully integrated with everything. There is no release yet. It's on release candidate, but really promising thing. Lot of SDK here you can use. The resources, you can check all of these resources if you wanted to start. So there is the two first link. It's about the learning on Microsoft. You will be able to see how to develop all of this well documented. And the other one, it's the Azure sample or Azure GPT RAG. These two GitHub repository, it's really cool because you have a lot of samples on how to deploy your own application. You can clone the repositories, start a new chat UI with just a few lines of code and just changing a few things. Really awesome resources here. And thank you. That's all for me. And thank you for your attention. I saw a few questions, Alexia, and I think we can jump on them. Okay, so I'm going to the start one. So for the image generator, it does not contain the history. In this part, what we did for managing the history, it's we are just changing the prompt. So because the image generation don't have this, the endpoint don't have this conversation history, it's just a single prompt. What we are doing is we are summarizing the previous one to have a single prompt sent each time. So in the chat conversation, if we wanted to have, we wanted to chat, what will happen is just we will do this summarization for to every time have a single prompt. For the from Bulend Malik for RAG implementation, citation, what we get? Can we bound them so that once we click citation, we see exact example and section from where text were taken is highlighted? Yeah, this is the case when we do the RAG. The prompt we created because we are putting the context of which document and which chunk we found. What we are doing is we are giving the references and in the response. And on this part, you need in the front end part to do some job to connect the chunk to the text value. So we need to develop, when you will just answer with the chunks, you will have some IDs displayed on the front end. So you will have to develop a new API to just get the corresponding chunk to this IDs. Second question from Ace. How do you configure the agent to keep track of the conversation, and what is the maximum conversation the agent can recall? It's the thing I said. It's about managing the length of a conversation. We are doing the summarization of a conversation with a buffer. So we are checking if the model we are using have 16K token of context in input. We just lower them to 4K to manage if we move from another model with lower context. And what we are doing is when we reach to 2K tokens, we are summarizing the previous conversation, and we try to never go through the 2K context token. So in this case, what you will have it instead of the call we will do to the models at the end if you have 20 messages, we will summarize this, and you will have at the end maybe 2 or 3 messages remaining because the previous one will be summarized. And this will continue like this. So you will have these 20 messages, we will summarize it, we'll go back to 3 messages, and you will continue to talk. And when you will reach this token limit, like at 30 message, we will do the summarization again and summarize the conversation, and you will have 2 or 3 messages left, maybe. Oh, okay. From Buland, Malik, can you please again put more insight on different roles involved in conversation chat, like system, user, assistant? Yeah, of course. I can go back in the presentation and show the, not the create image, but this one. You have 3 different roles when you are talking and you have your messages. The system prompt, it's really the one you are not displaying to the users. So when we did the chat, you will set up this once, and you will be able to give some guidelines on how you wanted your chat to work. For example, in our case, maybe you only want your agent to answer with some type of documents, or with a different format, with only Markdown, or if you wanted to deal with structured output, like in this case, we are just generating text, but you can have object, so technical object like JSON objects. In this case, in your system prompt, you'll be able to say, okay, answer me in JSON format only. You have some more tools from OpenAI to have this structured output, but this is one of the example. And the user and assistants, the user, it's all of the user messages. And the assistant, it's what the LLM is answering. At the end, when you have this length of this conversation, it's not necessary to send every time what the model is answering to you, because the large language model can generate a lot of tokens. So if every time you integrate this in your completion part, you can have a lot of token used. So what you are doing sometimes is just sending the user messages every time. So you have the context of all of your messages, but the user, it's your messages, and the assistant, it's the LLM messages, the answer you are getting from the large language model. And you will have alternate response, so user, assistant, user, assistant. Hope it's clear. If I check, Rashmi saying, hi, how did you implement chat history? Can you please show me insight on that? Yeah, of course. The chat history, it was a really complicated topic to handle. We'll just display the chat UI to show you. Because of the security concern, we wanted to secure solution and to save the history of the chat. And because of the timeline and what we wanted to implement, with our client, it's Swiss-based, and we have all of the GDPR regulation in Europe, and you can't save everything open like this. And we wanted something secure for our user and to have confidence to use the solution. In this case, we are not saving anything in the database. All of the conversation of the user, it's on the browser. So if I just take the messages here and just open, not in this one, just open a private browsing. I will maybe need to authenticate again. I'm just doing my authentication, and when I will call back here, I will have no chat history because we are managing all of the history in the web browser storage. It's a bit limited. You will be not able to share your conversation history between your different browser, or if you are on your mobile phone, etc. But in this way, we will be able to give security to our users. And to handle this, technically speaking, when you wanted to save this history, we are saving in the, there's two ways to save it. In the local storage, you have some limitation from 5 to 10 megabytes depending on the web browser, or you can save all of this conversation in the indexed database in the browser. In this way, you will be able to save a lot of things here. And what we are doing is just all of this conversation, it's stored in the storage. So differently, and what we are loading the application, we are just taking the ID of the conversations stored in the browser, and getting all the conversations saved each time we are chatting with the LLM. Okay, next one from Dream Big. Why and how are you using Docker? In this case, we are not using platform like Vercel or something like this who is doing all of this stuff. We have an expertise on the DevOps part, so we are managing and deploying our own solutions, and it's why we are using Docker. It's really easy to package our front end, our back end, and to be able to deploy our solutions. Can maybe go back to the architecture slide of this and show you here. Yeah. We are using Docker because it's really easy, and we already have a Kubernetes cluster, so an OpenShift cluster to deploy this Docker environment. If we don't have Docker or Kubernetes environment, you can deploy this with a lot of way. For the front end, you can have something with a static deployment on Azure. You can have something with Vercel, with AWS. You have a lot of way to deploy your front end and even the back end. But in a DevOps way, when you have a Kubernetes environment, you'll be able to manage all of this. And with the Docker, we can build once, deploy everywhere, and manage what we wanted to deploy and where. So it's easy for us to deploy a solution here, and we know we already plan to deploy outside of AWS. So we just have the same Docker images. We will just put it in a different cluster, and it will work well. The next one from Bülent Malik. I think Azure Search Service provide RAG out of the box and has vector database. So did you use that or set up your own vector database? Yes, for this, if I go back, yeah, still stay here. When we started, to just give a history back, when we started, we started with what we know. Basically, we have our Postgres database, we have our knowledge on Angular, on Python, and we wanted to develop our solution on top of what we know, and to start easy and to be able to keep our data on our side. And for example, we have internal Postgres database we are using now to do some vector database. And now, because we are scaling and starting to have a lot of documents, we are studying the Azure AI services. So we already did some POC with Azure AI services. It's really powerful, and we are just continuing to analyze this. We have Microsoft Copilot we can manage with SharePoint and doing all of this stuff. But yeah, this is if you'll be able to use all of this service, you'll be able to directly start with the Azure AI search. But just be careful on the cost of this. If you already have some solutions like the Postgres database, activating PG Vector extension, it's not expensive, but starting using some of the part, you need to just calculate your cost and what you wanted to do. The next one, what do you mean by semantic kernel? By Mulan Malik. Semantic kernel, it's an SDK. It's a tools provided by Microsoft to be able to develop agents depending on knowledge. So it's connecting well with Azure AI services. It's not just the SDK to do the OpenAI, but really to do the conversational things with and with the your indexes, your chat, your document, and doing a lot of knowledge. And you don't have to develop all of this because it's made by this SDK. It's a library. The next one from Ivan Rodriguez, how to handle complex workflow with decision branch and how to evaluate them. I try to figure out for this one. I think I got it. The complex workflow, in this case, we don't have them yet. We are starting to develop agents logic to be able to do this orchestration between one of the solutions. Like, for example, when you, instead of going chat by chat, you can have a single agent doing images, RAG, and just chat with your language model. To do this, we have some SDK with Python, with LangChain, for example. You have tools on OpenAI, so the LLMs will handle for you this complexity. So what you are doing is you are saying, okay, I have these tools working, and you are asking the LLM to say you which tools it's best to use. And in this case, instead of just calling a single call to the large language model, you are doing few calls. The first one is to handle the workflow. And after that, you can do the load balancing to the correct workflow you want it to go. And maybe to evaluate them, it's a topic we started, and I can show in the playground directly on this part. What we start to do is, if you, in the portal of Azure AI Foundry, you can go to this section, the tools, and you will see the evaluation part. This is the one dedicated for OpenAI services, if you just want to stay on OpenAI. And if you wanted to go on a higher level and you wanted to have for different models and to bring some, to have all of them in a single place, you can go directly in your Azure AI Foundry project this time, and you have this same evaluation part here, and you can create new evaluation. And you have lot of library for doing the evaluation here. You can just iterate on all of them, and you can evaluate your question and answers, and to try, even if you change models, to be able to be sure that you have the same answers. So you will not, for example, switching from OpenAI to Llama, the new Llama 4 models, will not break all of your pipelines or all of your user experience. The next one from Ricardo: how do you handle text extraction from BTF document from multi-column layout and many tables, some of which are embedded as image? What is the best technique for extracting and splitting? This is a great question. We did there is few things to be able to do with this. When we are doing the extraction, there is some libraries with Python you can use. For example, it's basic document to text extraction, and you can extract with this. It's just open source libraries, and you will be limited on the tables, because the tables content can be not well structured, and it's really complicated to extract them. And even the images, you need the vision capabilities to analyze an images. First thing, it's you can just screenshot, for example, if you have an images, not screenshot, but extract these images and call Vision API for OpenAI, an example, to get the result of this. And the same thing for the tables. This is complex to do if you have to manage it by your own. And there is the AI services here with document intelligence. And in this way, you can manage different type of documents. This is really good because it's complicated to manage all of the Office documents. And if you wanted to manage them, you can do the extraction from document intelligence. It's directly integrated in Azure AI search, and you can do all of this image extraction, the OCR, if there is some handwritten things, images, and something like this in your document, and you can do with all of these tools. The only remarks I can give on these tools, it's a bit expensive. You need to be careful. If there is some limitation with the open source tools, you can use locally in your backend application. But if you are using the document intelligence, can be expensive if you have a lot of documents you wanted to parse. So, for example, we have some rags with thousands and thousands of documents. Sorry. And if you call the document intelligence with each of these documents, it can be really expensive if you have hundreds of pages. Next one, again from Dream Big. How is using Docker on cost when hosting on AWS? On this topic, it's we are not using the deployment directly. Just coming back to the architecture slide here. The thing is, on this part, what will happen is we are not just deploying a Docker in the ECS, the Elastic Container Service of AWS, but in an OpenShift cluster. So we already allocated some resources, so we are paying for all of this infrastructure, and we have an amount of quota we can deploy services on top of that. So we have a dedicated cost monthly to be able to deploy our services on OpenShift on these dedicated virtual machines, and we don't pay directly for deployment for the Docker. And for the what we can pay, for example, it's the quota we are using for the databases increasing and etc. So the only thing I can say you in this type of solutions, just be careful on the cost of the network. And from Atharva Domal, sorry if I misspell it, how can we make connection between our client side and server side? Can you share which help to build real-time connection with send audio to server? To make to be able to do this type of things from client and server side, so the easy way the easiest way, it's just it's basic chat API. It's REST. It's a post call. So you are from your front, you are sending a message to your back. I don't illustrate it here, but you are all the authentication, all the headers, etc. In place. But it's just this this connection. But if you wanted to go further and you wanted to have this correct, well implemented, there is some tools you can do for the real time. So in this case, you have to sync your front and your back. I don't deal with the audio in real time, but I know, for example, there is some tools with Vercel AI SDK, which is bringing you a complete solution with back and front in the same place, and you can stream directly from your back to what you wanted in the front to be able to handle this real-time audio. And in this case, the most thing I think it's going to be to have this streaming process between the front and the back. And the thing I can say maybe to finish, it's we need to stream the answer. The backend, it's not static backend, but we are streaming the response to the front end, so it's reactive backend. You can have this in Python or Java, and you can deal with all of this. I think we are good, and we are on time. Thank you everyone for your attention and your questions, and see you next time.